Good evening. Hello, welcome. My name is Caitlin Bell, and I'm the Gene Jones Director of Public Programs here at the Nevada Museum of Art. Thank you for joining us for this evening's lecture. Deep Time Sea Dragons of Nevada is now on view on the third floor through January 11th of 2026. Just a little bit more time now. Thank you to our many generous sponsors and collaborators who made this exhibition and its programming a possibility. Tonight's program will wrap up with a Q&A segment. There will be 2 mics on each side of the theater. We ask that you just raise your hand and we'll pass a mic to you if you have a question. The mics will allow us to pick up your question for our speaker as well as for the recording. I would now like to introduce you to tonight's speaker, Dr. Ryosuke Motani. Dr. Motani is a professor and vice chair of undergraduate programs in Earth and Planetary Sciences at UC Davis. A specialist in vertebrate paleobiology, he studies the functional morphology and evolution of marine reptiles, especially ichthyosaurs. His research uses physics-based methods to explore how physical constraints shaped animal evolution. Notably, he discovered the first amphibious ichthyosaur, shedding light on the transition from land to sea invertebrates. Welcome, Dr. Motani.
Well, thank you very much for the kind introduction. And it's my great pleasure to be here to give this talk today. Thank you for the invitation. I was very excited when I received a request to talk about ichthyosaurs because I just love ichthyosaurs. I've been studying them for more than 30 years now. And the request was to talk about the ichthyosaurs of the world. So that's what I'm going to try to do today. Okay. Let's start from what ichthyosaurs typically look like. That's a typical ichthyosaur. This animal is called stenopterygius, meaning narrow flipper, basically narrow wing, from Germany. And as you can see, it preserves the body outline that looks like a fish. And the name ichthyosaur literally means fish lizard or fish reptile. So it's a very appropriate name. So that's a typical image of ichthyosaur, but these are the Jurassic kind. So these are slightly younger than what you get from Nevada. We get much older fossils of ichthyosaurs from Nevada. Now, the thing is, ichthyosaurs are very popular in UK, very popular, and also in Germany, but not very much in the United States, unfortunately. But given your fossil heritage, it really makes sense to really appreciate ichthyosaurs in Nevada. Now, so let's start by talking about the history of humans with ichthyosaurs, where ichthyosaurs were found first and who found it. And this actually has some kind of resonance until today, today's culture. Okay? So the first ichthyosaur fossil, I should say, that's been described by humans and named by humans, was collected by Mary Anning. And Mary Anning, as you can see, she was born in 1799. That's a long time ago. So that was in the Georgian era, before Victorian era, and she's actually older than Queen Victoria. So that's about her age, right? Now, she was a fossil collector. Living on the southern coast of England, there's a town called Lyme Regis, and that's where she lived. And she was born in this very poor family, and her father was part-time carpenter, part-time fossil collector. So when there's carpenter jobs, he would work. When there's nothing, he would just go to the beach, look for fossils. And Mary would go along with him, and pretty soon it became obvious that she was much better at finding fossils than he was. So you probably heard this one, she sells seashells by the seashore. It is said that it was made after her, but the only thing is that the shells that she was selling was not the shells that you think about. These were ammonite shells that she was collecting from the coast there. Okay. So, and that's Lyme Regis, that's where Lyme Regis is, where she lived. That's the town of Lyme Regis, and that's the east cliff next to it. That's where she would go to collect fossils along the coast. Right? Now, this is a small town, and when they have this religious at the end, that means the royalty came there for vacation, summer vacation. So it used to be just town of Lyme, which turned into Lyme Regis because this is a popular summer vacation place. And there are actually many interesting stories about this town, but I'm going to skip that today. That's the East Cliff. You can see that it's a pretty steep cliff with lots of limestones exposed like that. And you can see that a part of it is collapsing, basically. So this cliff is always collapsing to some extent. And that's good because every time you go there, something new is coming out of the cliff. And especially when there's a storm season coming from the south, it is basically a very fossiliferous, and it's the best way to find fossils to go there at the time. But of course, to get there, you can probably tell that when the tide is high, this is all submerged, right? You can probably tell from the bottom here. It's all submerged. And so you have to wait for the low tide, then you actually have to read the wave. There's a narrow path in between. So I tried it myself, and it was really difficult not to get wet. And I got wet running through there. I tried it many times, and half the time I got wet. Anyway, so it's a difficult one. So what Mary used to do was to come out here, and she would just pile up a lot of rocks. And there was this unwritten agreement among fossil collectors of the time. Whoever piles up the rock has the right to that pile. You're not supposed to touch somebody else's. If you do, next time somebody will touch yours. Right? So everybody respected that. That's what she would do. And it's actually a pretty tough life. And she was collecting fossils that way. And during the summer, rich people from London come. She sells the fossil to them. Then that's how she made a living at the time. Right? Now, then she collected this first ichthyosaur specimen back in 1809. This is a very famous specimen. And indeed, this specimen is still in London. It's in Natural History Museum of London. It's displayed there. So if you go there, you can see it. And it's very touchy to see this if you know the history behind the specimen. Anyway, this specimen was described back in 1814, and that was long before the first dinosaur was described. It's 10 years earlier than dinosaurs. So humans actually first met ichthyosaur as big reptiles from the past, not dinosaurs. But ichthyosaurs also got the society ready to accept dinosaurs in a sense. Now, initially, they did not know that ichthyosaurs looks like a fish. So that's an early reconstruction of ichthyosaur. They thought this was an amphibious animal that would come onto land, and you see that there's a plesiosaur, long-necked animal next to it. And plesiosaur from there is smaller than that big ichthyosaur. So they thought maybe it was the prey for big ichthyosaur like that. And there are many reconstructions like that drawn at the time. Very interesting. That's another one. This one, actually, ichthyosaur is biting plesiosaur. But it's not that we found plesiosaur bones from the stomach of this animal at this point. But anyway, so these are all kinds of fossils actually Mary found. Ichthyosaur, plesiosaur, pterodactyls, and these other marine fossils, including ammonites and squids, squid-looking thing called belemnites. She collected all of them. So this cartoonish drawing sort of describes what she did. She collected through life. So her contribution was big because humans didn't know that something monstrous like that used to live on this planet. And so everybody, like all sort of naturalists in London, they would come to Lyme Regis to talk to her because she was sort of really smart. She was always thinking about the fossils she was finding. So, for example, when she found that belemnite, the squid-looking animal, she went to the fish market, bought squid, and she dissected it and tried to compare the inside of the squid to the inside of the fossil she could see. And then she dissolved the ink of the fossil squid and wrote a letter to London saying, I'm writing this with this fossil ink. Do you want to see this specimen? And they would come and see it. So she was very much respected by these learned gentlemen from London at the time. So she was given a stipend from the Geological Society of London, which was new at the time. And when she passed away, she was given an honorary membership. Unfortunately, it was a boys' club, so she could not become a member, and she was not an aristocrat, so she could not become a member, but she was very much respected that way. Anyway, and that previous drawing was drawn by Henry Derabesh, who was a naturalist from London, and he actually ended up describing the genus Ichthyosaurus later on. So he named Ichthyosaurus. That's his cartoon. He was a very funny person, so he thought, maybe this could have been different way, the other way around. So today, humans are looking at ichthyosaur skull and lecturing on that skull, but maybe it could be the Professor Ichthyosaur lecturing on human skull. And so he had that kind of free way of thinking. So that's early 19th century. That's actually quite remarkable. Anyway, and then other people who would come at the time included William Conybeare, who also described Ichthyosaurus together with Henry Derabesh, and then William Buckland, who ended up describing the first dinosaur. So all of these people sort of grew up, in a sense, scientifically in Lyme Regis with Mary Anning. So that was the beginning. So that's how humans met ichthyosaur, but at the time, we didn't have the right idea of ichthyosaurs. It wasn't until a few decades later that we realized actually ichthyosaurs were really fish-like. And that's because of the discovery from southern Germany, especially near the township of Holzmaden, and that's the old townhouse of Holzmaden. So they have very nice houses like those in that region. And it's a small town, but outside of the town, there are many quarries like that. And these quarries, again, are limestone quarries. But the limestones are interbedded with shale, oily shale. And these shells, actually, if you ignite it, you can burn it. It's very oily. So during the war, World War II especially, they would dig there and try to get some fuel out of just burning the shell, I guess. So that was happening. What happens is that when people do that, they cannot avoid finding all the fossils in there. So this was back in 1916 when a large number of skeletons lying next to each other were sort of discovered like that. And some of them, you can probably see that, had body impressions, and the others didn't. And that one had the body impression, and that one had it, the others didn't. So depending on the place, you might have a good preservation for the soft tissue or not. And if you have more oil, you'll tend to get more body impression like that. So anyway, so that was an impressive place. And from there came that kind of fossil. And then we realized, ichthyosaurs were not all that nasty, ugly-looking thing on the beach, but that they were more pleasant-looking animal, like the dolphins probably. Although probably not as smart as dolphins. So since that time, this has been a typical image of ichthyosaurs. Okay, so that's the humans meeting ichthyosaurs. Now let me talk about when they lived, the time period when they lived. So this is one of the ways to depict the history of this planet. So today is this line here, and if you spiral back this way, you go back to the beginning of the planet and then the beginning of the universe right there. And this is, that way, it's about 4.6 billion years ago. Anyway, we don't worry about this really deep time. That stretch right there, that's called the age of dinosaurs. And so age of dinosaurs, of course, dinosaurs are ancient, but compared to the whole history, they're actually quite young. They are just newbies like us, in a sense. We are even newer, but they're pretty new too. And if I just straighten this thing, that's the time axis right here. And there are just too many names, I know. So let's not worry about something outside of age of dinosaurs That's all you need for today's talk. So the age of dinosaurs, called the Mesozoic, is divided into three parts called the Triassic, Jurassic, and the Cretaceous. And Jurassic, of course, you know. And the Triassic you know because that's Nevada's ichthyosaur fossil horizon. And Cretaceous, I guess, you might know if you like mosasaurs and T-Rex and so on. Okay, so you will see these three colors, these three names in the next several slides. Okay. So I just blew it up like that. And during the age of dinosaurs, dinosaurs lived from about the very beginning of the late Triassic to the end of the Cretaceous. And it's just that the late Triassic, it's so long, it takes more than half of the Triassic, and that's why it's so low. Starting point is so low. Anyway, ichthyosaurs, they actually appeared pretty soon after the beginning of the Triassic, but they did disappear again earlier than dinosaurs. But they lasted for a long time. And they were very, very successful. They were everywhere around the world at one point of time. Now, at the beginning, they looked like this skinny, narrow animal, which looked like the lizard that got into the sea and developed flippers instead of the limbs. But then, within about 30 million years, they gave rise to the first fish-shaped ichthyosaur, although this particular one is even newer, but in about 30 million years, the first kind that looked like that appeared. And that oldest record comes from actually Canada. So, starting from more lizard-looking thing into the fish shape, and actually the first fish-shaped animal is these animals right here. So by that time, they finished the transformation from this lizard-looking animal to fish-looking animal. So when I say ichthyosaurs of the world, depending on the time period, you get different kinds of ichthyosaurs, actually. And another thing I want to point out is that at the beginning, they diversified really quickly. So many species came out, and so many just didn't last. There were lots of experiments going on, and just a few survived the game in the end. So let's look at the fossil record briefly. Let's just run through. This is the Triassic, early Triassic. So that's the beginning. And the earliest fossil of ichthyosaur was first discovered in Spitsbergen. And this is this was discovered in 1929. Then in China in 72, and Japan in 78. Then in this century, something came out of Canada and Nevada. Fossil Hill has some lower Triassic fossils, although these were incomplete. So from the beginning, they were quite well distributed, but only in the northern hemisphere at the time. Okay. And these ichthyosaurs looked like those, so the lizard with flippers. That's how they looked like. Then in the middle Triassic, they were still mostly in northern hemisphere, and most famous is probably Switzerland, which yielded Mixosaurus, and they also have symbospondylus that we have from Nevada. So Mixosaurus, symbospondylus, these are also Nevada kind of animal, although we don't have the exact Mixosaurus here. And then Nevada fossil came out, that's symbospondylus. You saw the skeleton upstairs, that's the skeleton. This is from the 1908 paper by John Merriam of UC Berkeley. Okay, and then this century, more started to come out from China, and this is actually related to that symbospondylus. And these animals were sort of elongated animals, mostly elongated animals, symbospondylus type, or more sort of fish-looking animal called the Mixosaur type. So Mixosaur type animals started to appear, and they started to look a bit more like later fish-like ichthyosaurs, although their tail fin was still not symmetrical. Right. Then in the late Triassic, they spread to, they stay the same thing. For the first time, they are found in southern hemisphere too. This is from Chile. And this one is Californian animal. Californosaurus is actually an ichthyosaur, which is not appreciated by Californians as it should be. And of course, then discovery was made in Nevada, famous Shonisaurus, that's late Triassic. And Kilauea from British Columbia, Canada, came in towards the end of the previous century. And this century, there are tons of fossils that came out of China. So many, many fossils just came. And by this time, these ichthyosaurs were more chunkier than before, not as elongated, although top kinds were long-bodied. This was a short-bodied animal. And this short-bodied kind led toward, excuse me, typical fish-shaped ichthyosaurs later. Then in the Jurassic, that's early Jurassic, we somehow have most of the record from UK and Germany. And these are the typical fish-shaped type. This is Steropterygius, that's Ichthyosaurus itself, as well as something called Temnodontosaurus, which is Mary Anning's animal, basically, the first animal. And from these places. And we do have some North American record, but these are very, very fragmentary. So early Jurassic record, this is the best time for the best kind of fossil, but it's only from Western Europe at this time, at this point. And these are how they looked like. Then in the middle Jurassic, we lose track of them. We only find them in South America, in Argentina only. There are actually a few from Germany and France too, but the best one come from Argentina. Then in the late Jurassic, they started to spread around again, and this time they gave rise to somewhat big form, like the 4-meter kind of animal. A famous one is Ophthalmosaurus from UK, and like the same thing, Ophthalmosaurus from Wyoming is in the Carnegie Museum. And in Argentina, they have something called Capelisaurus, which is pretty remarkable. And then in the Cretaceous, there again, now this is really worldwide. We have, the first one came from Germany, but then Wyoming has another one, and then Australia has a good record of them, and Canada has it, and South America has it. And the Cretaceous is the youngest part, so it's most recent. So we have the best preserved fossils from this time period. So that's sort of a very quick overview of all kinds of ichthyosaurs through time. Of course, I didn't cover like 20% of the species, but that sort of covers the variation, maybe 80% of the variations. So one thing to note is that they were very abundant. If you go to the Mesozoic strata, find a marine reptile fossil, chances are that's an ichthyosaur. Others are rarer. Ichthyosaurs, diversity-wise, the count of the species was less than plesiosaurs, but individual number, it was big. So they were everywhere, and they were the main player in the sea in the age of dinosaurs. Now, these days, we found some cousins of ichthyosaurs. And these cousins, you're probably curious what they might look like, right? So I actually saw some of the drawings. So that includes this animal called Cartorhynchus, which unfortunately doesn't have most of the tail. It would have been about that long, but that's just a guess. And it's a very small animal. And this animal had a very strange flipper and a lot of features that are sort of land-looking features still. So maybe at least when it gave birth, it could have gone to land, that kind of animal. That's another one related to it called Scirochromos. This is a much bigger animal. The complete tail is there, which was actually straight in life. And heavy-looking animal, weird animal. So these things are the cousins of ichthyosaurs. So that's a new group that we discovered this century, and we call it Nasarostrans, and they gave rise to ichthyosaurs. You notice that the ichthyosaurs, the typical ichthyosaurs, have some kind of tail fin. These animals did not yet. We have yet another group that's outside, called Hupesuchians. This group had been known, but they were not recognized as ichthyosaur cousin until recently. And these are really weird animals. if you zoom in, the body is filled with bones. Nobody wants to eat it, right? And so they were the worst kind of prey. They protected themselves quite well against predators because of that. And looking at the mandible, it's unusually slender. And how slender? Well, that's the animal we have here. It's a bit more robust than this one called pelican eel, but it's more slender than the pelicans. That's how slender it is. And these slender jaws are usually associated with pouch, throat pouch, like that. Pelican eels have it, pelicans have it, and baleen whales have it. And they do something called lunge feeding. So the chances are Hupesuchus was also doing that back in time. So that's another kind of Hupesuchian. This one is very different, and they have a very different lifestyle. I don't have time to get into this interesting animal. So they come outside right there. So these are the cousins of ichthyosaurs. So we are improving our knowledge of ichthyosaurs over time. The next question. What were the largest and smallest ichthyosaurs? That's a good question. The largest one, I say, is this animal called Shonisaurus silcaniensis. And that's not only because I helped them dig it out, but I could measure it in place when it was still in the rock. So I took this photograph. I was at the level of the shoulder of this animal. That's where the tip of the tail was. So it was a huge animal. It was from this riverbank, and you had to walk a long distance in this bare country. You could not carry heavy equipment, so you have to hire a chopper. But this is a valley, and the valley wind is very bad, so chopper almost dropped the heavy equipment on top of us. We had to run away, and that was very scary. Anyway, so that kind of thing happened. And this animal is now on display at the Royal Trail Museum. That's the upper body. Lower body is mostly not there, but the tip of the tail is there. So that's how big it is. It's about at least 20 meters, 21 to 23, I would say, meter. And the original paper said, I think, 23 or 24. And that was the direct distance that was measured on the ground. So that's the biggest. Now, of course, the name Shonisaurus sounds familiar, right? This was actually the second species of Shonisaurus. And Shonisaurus popularis from Nevada was the first Shonisaurus. And I still believe that some individuals of Shonisaurus popularis was probably as big. Although the good skeletons are not as big, unfortunately. So you have to give it to this animal, the biggest ichthyosaur. But the Shonisaurus is certainly, the Shonisaurus popularis from Nevada is certainly one of the contenders to be the biggest ichthyosaur. And in the future, it might change. Now, apart from that, the biggest ichthyosaurs are sort of named based on some fragments. So that's just a part of the lower jawbone called angular. And they say this animal was more than 20 meters long, or 25 or some ridiculous number. But of course, when you have only those bones, you could not really tell how big the animal was. A lot of guessworks. And you probably saw this animal upstairs, Sympospondylus and Yangoram. And this one, it's a big skull, isn't it? About 2 meters long. And that skull is certainly really big. And unfortunately, the whole body is not there, but if it's like the other animal called Sympospondylus, either Piscosus or Petrinus, depending on who you ask, that one, then this animal would be easily 20-meter range. So it's a pretty big animal. And unfortunately, we don't have the body. And the scary thing is that, for example, do you know this dinosaur called Pachycephalosaurus? This one, when I was a kid, the skull was the only thing it was known. And it's a very nice skull. And the estimated size was 12 meters. Later, they found the skeleton, it was only like 4.5. So when you estimate based on just the skull, you could get it really wrong. But in the case of simple spondylus, I think it's quite okay. But still, there's some kind of risk there. What about smallest? Well, this Cardoringus that I talked about earlier would have been the smallest, although we don't have the tail for sure. And if you base it on a complete skeleton, it would be this animal called Chaosaurus chaoshanensis. And even the biggest individual is only 70 centimeters. Some individuals are like 30 centimeters. And males are bigger than females. So some subadult females are only about 30 centimeters. So that's a pretty small ichthyosaur. Good size range. How does it compare to whales? Well, today's whales are big, right? The baleen whales, the blue whale. This one is, I think, I actually communicated with the whale specialist, blue whale specialist, and they said they can agree up to 31.5 meters as the biggest recorded length of the animal. Head alone is that big. So that's sort of, we couldn't beat that animal. It's the biggest animal ever. And whereas the smallest whale would be this porpoise from Baja California, which is really small, smaller than humans. So baleen whales, which filter feed, tend to be bigger than the toothed whale. So the smallest one is the toothed whale. Now, of the toothed whales, ichthyosaurs were not filter feeding. You have to have baleen to filter the water to be like that. So we couldn't really compare ichthyosaurs to these animals. So I just removed them. And I also figured out these animals. These are deep sea squid eaters. They don't feed near the surface. They only feed at the very deep sea, at least like 1,000 meters. So very different ecology. So if you remove them, the biggest toothed whale would be the killer whale. And that's the true top predator of the sea. So it may be deceiving to you, but actually top predators are not the biggest in the sea. Top predators, 10 meters, if you're 10 meters, you're a good top predator. 6 meters would do because most orcas are about 6 to 8 meters, right? And they are still the top predator. So that's how it works. Now, what about our ichthyosaurs? Shonisaurus, that's the Canadian one, that's the Nevada popularis here. They are the biggest. And the smallest would be that Chaosaurus, which is even smaller than this Bakita here. But these typical ichthyosaur predators, they are about the size of the killer whale. So I always wonder what's going on with these animals, because they are sort of unusual in size. Now, simple spondylus, the more complete skeleton would be about that big, but that young worm could be that big. Again, that's a top predator, but it's not a big for a top predator in my sense. But if you look back in the whale fossil record, they actually did have 20-meter toothed whale that was eating, like the top predator of the time. And but of course, both of them are slender. So body mass-wise, they are probably fine. I mean, they are probably not much heavier than the killer whale. So in that sense, they're still about the top predator size. So that's the largest and smallest. The next one. What was the most vicious ichthyosaur? That's some people are interested in this, so I always have to include something like that. I would say it's still this Marianning's ichthyosaur called Temnodontosaurus. And this animal has been found with reptile bones in the stomach, although fragmentary ones. So that means they did eat other reptiles in the sea, and they were attacking these animals probably, right? Now, this picture was taken by my professor, Chris McGowan, and he always joked that this animal was too big to fit into a photograph. And he had these two photographs to demonstrate it. But this is before the zoom lens. So you have to walk all the way back to the wall and try to take it. And yeah, you do need two pictures too. And I tried it myself, so I know. Anyway, so but it's not the biggest. That skeleton is not the biggest. And this one's only about 6 meters long. It's big, much bigger than me. And they have pretty healthy teeth like that. And that was in the news a few years ago. they found a very big skeleton of that, about 10 meters. And the biggest skull I saw of this species is about 2 meters, a bit slightly bigger than 2 meters. So it's about the Sympospondylus yangurum size skull. So these animals were vicious animals. Now, it has this sister species called Temnodontosaurus eurycephalus, which is a smaller animal, but it has really big teeth for the jaw. And that sort of reminds you of something like orcas. So this is probably another really vicious animal, nasty animal in the sea. If you compare it to mosasaurs, it's not smaller than mosasaurs. It's as big as mosasaurs, biggest mosasaurs. That's another Temnodontosaurus. This one's from Germany. And again, this particular species, the best skeletons are only about 6 meters. But I tend to drop this. Sorry about that. Biggest animals are about that, but biggest animals are about 10 meters, based on small, like a more fragmentary specimens. So it's about the same. And they are found with some reptile bones in the stomach. Right? So these are vicious animals. Then from Nevada, we have this Teraton which has the teeth with cutting edge. And it's a pretty big animal, though it's just a part of the skull. That's the eye socket here. So we could not tell how big it was. We don't have the stomach contents to prove what it ate, unfortunately. But in the future, we might get something, right? And then that yangurum upstairs. This one, again, we don't have any stomach contents, unfortunately. But chances are we might find something in the future saying it was one of the very vicious ichthyosaurs through time. Now, in terms of the stomach contents, this pretty small ichthyosaur, only about 5 meters long in total. And this animal actually has a chunk of bones in the stomach. And these are all made of another reptile. And what it turned out to be, and that's the teeth of this animal. So this animal was too greedy. So there was a pretty big prey animal. It chopped the head off and the tail off and swallowed everything else. And it was in the stomach. Obviously, it's too greedy, and it could not digest it. And it's probably died not too far away from the place it sort of captured this animal. Because we found what seems to be the tail of this animal nearby, only 10 meters away. So that kind of thing happened. This is, although this is small, certainly this was a vicious animal. And I would not want to see this animal in the sea. So these are the vicious animals. And to be fair, I always have to talk about the cutest ichthyosaur. And not many people agree with what the cutest one is. But my cutest is that one. This is called Leptonyctes muiri. This is from it's close to Lyme Regis and that area. And you can sort of see that this is smiling, right? And big eye. It looks like a kid smiling. So that's the cutest ichthyosaur. And the whole animal's only about that big, probably. We only have that part of the body, but the whole animal's about that big, probably. The cutest ichthyosaur. Now, but personally, I have my real special cutest fossil, which is this one. And I have to explain why it's the cutest, but to do that, I have to get into the next question. So, how do you look for the earliest ichthyosaur? So I've been just showing a lot of ichthyosaurs, but it could get boring, so I'm just going to show you how you try to find them in the field. So you actually start by thinking where to go in the world. If you were to find the earliest ichthyosaurs, it probably lived in a place where it was easy for reptiles to live. So, where in the world today are reptiles getting into the sea? And that's actually Southeast Asia. That area is where the highest concentration of seagoing reptiles live. And there's a lot of things about that, but that's where the productivity of the sea is really high. And the western end of the big ocean, that's near the equator. That's a very good spot. So, today it's there. What about back in time? Well, back in time, the continents were arranged differently, but there was actually a big ocean. At the western edge, there were islands. And if I stretch it, it looks like that. So that's where we should go, probably. Right? And it turned out that that's South China to Southeast Asia. They were just small islands. They were eventually pushed against each other to make Southeast Asia and the southern part of China, basically. So you would go there. And also, back in time, that part was the only humid part of the world. This was right after something called the Permian mass extinction that wiped out more than 90% of the species in the world. And that's because of this very bad warming trend, global warming trend, that did not actually stop after the mass extinction. It just kept on going up. So the Triassic that followed was a hell of a time at the beginning. But that's when ichthyosaurs appeared. And that was the only humid part of the world where you would see trees, and trees would capture nutrients for you, and that wash into the sea. So that's where probably reptiles would live. Anyway, and to find them, you have to go to southern China, especially Anhui province there. And there's a big lake called Chaohu Lake, which is the fifth biggest body of fresh water in that country. And on the outskirts, there's a place called Majiashan, meaning Ma family's mountain. That's how it looks like. You're probably used to seeing rocks horizontal, right? There, it's vertical, because land was pushed from the south, and it's all tilted over 90 degrees. So it's just standing like that. But this is wonderful, because if you walk towards the right, you can get to the middle Triassic. If you walk towards the left, you can actually go down the hill. Then you'll be down at the Permian mass extinction boundary. It's all dark there, all black, actually. So that's a very remarkable place to look for fossil. So what we did was, so that's the Permian mass extinction. We are looking at these rocks here, and especially in the previous photograph, you saw these two time periods in the view. Then we could go all the way down to the Permian. So that's where we started looking for fossils. We first decided that, okay, let's go to the top and let's put number 1,000 here. That's bet 1,000. Then next bet is 999, 98, 97. We just kept on going down, put all the numbers. Not just one outcrop, many different outcrops. It took a week, not more than a week, actually, a few weeks. And then, in the end, we discovered that there are actually 600 beds in the region. Then once this was set, we just set out to look for fossils. And that's when I found that fossil. And if I were to explain the situation, I had the National Geographic grant to go there, and when you get these grants, you of course say, okay, that's a unique place. If you go there, you will find unique fossil. And then they gave me money, I go. For the first 10 days out of 12 days I had that year, I didn't find anything. So I was getting really nervous, and I was just walking around every day until that day. On the 10th day, I finally bumped into this animal. That's the head, body is curling, that's the tail. And I really thought this animal was smiling at me, but although you couldn't really see, right? And the good thing is, and that's why it's my cutest, anyway, the good thing is it wasn't alone. There's another ichthyosaur, that's the head, that's the body going this way. That means there must be more if you look up, and indeed, it came from there. So we started digging at here, and a lot of fossils came out. So they would come out like that. You bring it back to the lab, then prepare it, and it's a beautiful ichthyosaur coming out. We got many, like about 30, more, not quite 40, but the 35, 36 skeletons that year. And it's still coming from there. That's where we found that Catharyngus that I talked about. It came from right there. And also that Sclerocomus. These ichthyosaur cousins came out of there. until that time, we didn't know this kind of animal existed. So that's how you look for the earliest ichthyosaurs. You first have to decide where to go, then you have to sort of invest time and try to find them. So that's what you do. Okay, I have 1 minute left, so let me get to the conclusion. So ichthyosaurs were the most abundant marine reptiles in the dinosaur era, basically. And some ichthyosaurs were the top predators of their time and place, including those from Nevada, like Symbospondylus, maybe Shonisaurus too. And then the largest ichthyosaurs were a whale size, like Shonisaurus, small whale, not the biggest whale, but still sizable whale. And that, of course, includes Shonisaurus from Nevada. So you have a lot to be proud of. And the ichthyosaurs typically had a tail fluke, but the earliest cousins still had the straight tail like a lizard. And that transformation is now being understood these days. So, and I'd like to thank my professor, Chris McGowan, he's English, and John is his professor. And this was taken in the basement of the Natural History Museum in London. And that they actually took this place down. They took putting a blue whale skeleton on display. So it's no longer there. And I also like to thank my long-term co-workers, Andrea Tintori from Milano and Gian Dayon from Peking University. We've been working together for more than 20 years in China, and we've discovered so many fossils together. And finally, I'd like to thank you for coming and listening.
Any questions?
Hi.
Hello.
Did you say there were fossils in Western New York? From Western New York? I thought I heard you say something about fossils from Western New York.
Western New York.
Because I know the Eurypterids.
Right. No, ichthyosaurs are I probably said it wrong. It's not from New York, but it's mostly from Wyoming, and then, of course, Nevada, and then California. These three states are the ichthyosaur states, I think. Yes. Yes.
Yes.
So I guess mine was inspired by some of the things which was your maps at the beginning that showed distribution of different ages. And I think you partially answered it in talking about how you decided to go look for the oldest ones. But there were none at all showing up in Africa? Are there no marine Mesozoic rocks, or they weren't in a place where it was humid in the land, or why the distribution other than just accident of what you happened to find?
And that's an excellent question. You observed it right. We don't have any African ichthyosaur. And Africa is not known for a lot of marine sediments from the age of dinosaurs. They do have Cretaceous, so they do have mosasaurs, and especially northern Africa, right, and northern to northwest Africa, and so they have mosasaurs and plesiosaurs from there. But by that time, ichthyosaurs were extinct, so we don't see them there. And then early on, at the very beginning of the Triassic, they have some fossils from Madagascar, not Africa itself. But these ones don't include ichthyosaurs, unfortunately. So probably ichthyosaurs are not there yet. Okay. So yeah, at this point, that's all they have.
So I'm a docent here, and we have our display of the exhibit of the ichthyosaur. And we were told that they are warm-blooded, give live birth, and I forgot the third one. I was thinking, what's the third one? Anyway, three things, but they're not mammals. Can you tell me why they aren't mammals?
Okay, so mammals.
Oh, they breathe air.
So they do breathe air, yes. These are air-breathing animals with lungs, so they would have had to hold their breath coming down. And so that's for sure. Why they are not mammals? So we tried to put them in something called a tree of life. So this is where that depicts the blood relationship all the species live in today. And so reptiles are here, mammals are there, and the mammals did have a reptile-looking ancestor in the past, but this is a long time ago. Anyway, and so to be mammals, the true mammals, you have to have certain characteristics. And most important one is that you have to feed the babies with the milk. And really, there's no feature like that. Another thing is that the mammalian skull and the reptilian skull look very different from each other. And ichthyosaurs clearly have reptilian kind of head. So they're related to reptiles. They're actually a part of the reptiles. I hope that answers.
Yes, very good. Thank you.
I think the extinction of this genus was quite rapid when it finally happened, and it happened, I believe, before the Great Basin completely dried out. Can you comment on whatever we know about the kind of disappearance of this genus over the time?
Oh, in Dinosaurs, or yes. So, disappearance of the genus over time. That is a very good question. So, even if the basin is there, probably you need some depth for the animal to be active, because this is a pretty big animal, and all the resources it needs. So it makes sense that this space and resources it needs disappeared before the total basin disappeared. That's what I would say. How much earlier it should be, I do not know, really. Does it answer your question? Yeah. You're welcome.
Yes. I've been puzzled for a long time about how we get such large ichthyosaurs so early by the middle Triassic, where you're looking at maybe possibly 20-meter ichthyosaurs from the Permian extinction and things too. And then I think there's a rib bone up there from New York Canyon that looks pretty damn big at 205 million years old too, though. So somehow or other we had these huge ichthyosaurs, and then they were smaller. How did we grow so fast, and then why are they smaller after that?
So that is a very good question. I wondered about that too in the past, and I'm still wondering about it too. But basically, it has to do with what's called the productivity level of the sea. And this goes back to how much plankton, phytoplankton there is. So basically, in the sea, all the nutrients come from photosynthetic phytoplanktons. That's the biggest contributor, the primary producer there. So if you have many of them, the zooplanktons would eat them, then the fish would eat zooplankton, then reptiles would eat fish. So that whole productivity has to be big enough to sustain large species. It so happens that the late Triassic was one of the times when that productivity level was high. Why? That is not known. One thing we do know, is that there's a big difference between middle and the late Triassic. In the middle Triassic, sympospondyls and those things, although they're big, these are nearshore animals. Shonisaurus is probably not. Or around the world, coastal marine reptiles disappeared towards, from the end of the middle Triassic to the early late Triassic. And so that transition happened. And so the Shonisaurus was sort of more of a deeper water ichthyosaur. And then they could be bulkier, I think. Sympospondyls still 20 meters long, although it's skinny. There must have been enough prey near the coastline at the time.
Hi. Thank you so much for being here. I learned a lot. This was really great. I have kind of two questions. The first was that area in, I think it was Canada, that really remote area where you found that really large ichthyosaur. Had people scouted that location and found sign? Was that kind of a known location based on the geologic evidence? How did you actually end up finding that? Because it looked like it was in such a weird place. And then my second question is, has climate change affected, I guess, maybe the amount or the kind of fossils that we're seeing? Is climate change eroding more areas? Is it, are we encroaching on more habitat? So humans are just kind of digging up more information? Thank you.
Okay, so let's start from the first part. Sorry, I was starting to think about the second one. I forgot the first one. The first one was about how to get to that Canadian locality, right? So yeah, we usually start by asking local people, because local people would have walked around. And there are two kinds of local people. So local hobbyists, hikers, as well as local geologists. And in that particular case, it was the geologist. So geologists were trying to make a map, and they spotted it. And it was noted in an old report, but nobody really paid attention to it. Then somebody dug it up, and we went there. And for the second question, global warming, has it sort of accelerated the erosion to reveal more fossils? You know, I do not know. If there is a difference, it's probably not that noticeable, at least in places I go. It's erosion. I mean, erosion is always happening, yes. But I always felt erosion was fast everywhere. I don't really know if it's faster now, at this point. Maybe in the future, yes. Yes.
My turn. Yeah, I've had a couple of questions. When I look at the skulls of ichthyosaurs, I find a couple of features that seem to be weird to me. And you touched on one of them with the comparing them to near surface feeding mammals, marine mammals. But when I look at their skulls, the eye sockets are gigantic, which often you would associate with something in low light conditions. But the other thing that conflicts with that is when I look at those skulls upstairs here, the little port at the top of the skull that they'd be breathing through is tiny for that size animal. I don't know if you had any ideas of what's going on with that.
Yes, let me see. Actually, that is one of the things I removed from this slide to fit it into 45 minutes. So I actually have it after that. So ichthyosaurs have unusually big eyes. And I actually have a paper on that in 1999 in Nature. And but before getting to there, you were talking about that small hole right there. That's actually the third eye opening. Their noses are here. So noses are, I guess, big enough, yes. Then eyes, these are really weird. And then when they are three-dimensionally preserved, it covers more than a hemisphere of the eyeball. It's quite remarkable. And you can measure the diameter, you can measure the aperture size. And today, the biggest eye goes to the blue whale, and it's about 6 inches across. And then giant squid, that's about 10 inches across, although it's not directly comparable. Biggest eye of the vertebrates go to the blue whale. Biggest eyes of all animals go to the giant squid. Ophthalmosaurus is much smaller animal, but it had the eyes about 9 inches across. It's huge. And Tempelodontosaurus, the biggest one I measured, was more than 10 inches across, although it's a much bigger animal. So let's say this is the body size on X, eye size on Y. The whales have that kind of eye size. And the point I'm trying to make is that we all have about the same eye size for the body. So that's the whales. That's the dinosaurs, except sauropods, which have that tiny head for the body. And these are the ungulates, hoofed animals. These are the pinnipeds, that's the sea turtles. So and the humans, we all tend to have about the same eye size for the body. But something like the penguins and the owls, they tend to have bigger eyes. These are nocturnal animals, all that's seeing in the darker part of the sea. And giant squid would be there, although it's not comparable. And ichthyosaurs, typical ichthyosaurs are there. And the ophthalmosaurus, meaning eye lizard, is even bigger. So it's really weird. So it's the biggest eye for the body of any vertebrate ever. And by calculation, you can actually compare it to camera lens. In the old days, there's no zoom lens, right? You had just a single focus, and there's something called F number, how bright the lens is, and that can be actually calculated for your eyes. If you do that with ichthyosaurs, you can tell that they would be able to see quite deep in the sea, like 1,000 meters. So it's quite possible that Ophthalmosaurus, that animal, was a deep diver like that. And just like some of the deep diving whales today to hunt for deep water squid-looking animal at the time. But of course, not every ichthyosaurs were like that. Ophthalmosaurus only is the only one. Okay, yeah, that's another question, so let's not get into that. Oh, okay. Anyway.
All right, we are at time. So thank you all for joining us, and thank you so much, Dr. Motani.
Thank you.